Good afternoon, everyone, and thank you so much for inviting me to this presentation. I apologize that I can't be there in person, but it is a wonderful opportunity to talk about these types of records that both Brett and I are passionate about, and I greatly appreciate this to hear all the other presentations that we've been able to hear in the past 2 days. So I am a processing archivist at the Electronic Records Division at the National Archives. The National Archives of the United States provides direction, guidance, and assistance to all federal agencies in managing their records throughout the data lifecycle. And we preserve electronic records with enduring value in non-proprietary formats, which certainly can be a challenge for compound records such as geospatial and computer-aided design records. And we not only preserve these records, but we provide access to these to the public. So during my talk, I'd like to expand on how our Electronic Records Division preserves federal archival geodata. So the Electronic Records Division, or RDE for short, we accession, process, preserve, describe, and provide access to permanent federal electronic records. And specifically, we deal with born digital records. We also deal with material that has been digitized by agencies, as long as the digital copy is what is considered the record copy. So as Brett had discussed yesterday, all records used by federal agencies are scheduled, and the majority of the records could be deemed temporary in many cases, and then what is deemed permanent, we either have a record copy that might be analog as paper, as we have an extensive collection of paper maps and architectural drawings, or we might have digitized material, and now we have born digital geospatial material. And our Electronic Records Division program dates back to the 1960s. However, we do have some records from the World War II era and records dating back as far as the 1800s, which I'm sure is very young compared to some of your holdings. And we have textual records such as electronic telegrams, emails, we have word processing documents, digital images, and web records, structured data, and geospatial and CAD of various degrees. Our division has 3 branches. We have a processing branch, which Brett and I are a part of, a reference branch, and a digital preservation branch. Currently, our holdings, NARA has legal custody of approximately 800 terabytes and 10 million files of federal electronic holdings in our current repository. This does not include presidential records or records that have caveats to their current preservation that we're waiting until they can be ingested into our new cloud-based repository. And all of our holdings, most of the electronic holdings are transferred via direct offers, so we communicate with our agencies and get determine what's eligible and how they'd like to go about transferring these records. And these are usually in a scheduled manner, perhaps annually, or we do it every 2 years. It's all determined in the record schedule. So currently, these are an example of few geospatial holdings at NARA, and we have the link here, which whenever you can go to the slides, you can see on our website a report of the type of geospatial holdings that the National Archives provide access to, and it gives a description of each of these projects. As you can see, the type of geospatial records we have, a lot are from the Department of Interior, and we also have the Department of Transportation, the railroad network system that Brett had mentioned yesterday. We have maps of our national parks, of our wilderness areas. We have maps from NOAA of certain flight operations, as as well as fish and wildlife. We have a great variety. We also have certain maps. These maps that are all publicly accessible. We'll have some maps that have access restrictions, but we have extensive holdings of terabytes of this type of data. Although this list might not seem the longest, this incorporates millions of files and terabytes of data. I will get right into our validation process. So when we receive a transfer of records, one of the first steps we do is ensure that the files match the schedule and that they're an accessible criteria so that these records are not proprietary. They are ideally human readable, or that we have a tool that can read that, such as the every shape file. We have tools that would be appropriate since that is not something that you could open up in a notepad or Word editor. This whole process, we're trying to establish physical and intellectual control. We will see what we have here, what different types of file extensions, what is the entirety file count, the byte count, when were these records last modified. And so one of the first steps, we register the accession in our accession management system, which has every transfer that we've received. And then we are matching the records to the schedule, and then we run a virus scan because we want to make sure that nothing malicious was attached in that transfer process. And then we run a niche tool. You can see a screenshot up here. It is a file lister. And this, you point it to a directory path, and it will scan subfolders, and it can also create a hash at that point, a SHA-256 hash, so you can see that the data has not changed in any way from the transfer to the moment that it's being put into the repository and afterwards. And this helps, especially when I process the National Atlas, which is over 1 million files. This tested the capability of our tool. I actually had to work with our IT to increase the memory allocated to this Java tool and allow it to keep processing and use more memory so it could list all 1 million files, which identifies a limitation on our tool and then a new workflow to do for these large accessions that are more and more common now. Now I'll move on to further validation. So for geospatial files, specifically every shape files, as we all know here, these are components that they're compound files with many components, and you need these required components to open up the shape file and make sure that you see points, lines, and polygons as expected. So our division developed this niche tool to verify that a shape file, the SHP component, contains coordinate data, that the spatial index file contains index information, and that the dbase table has attribute information, that none of these tables or files were potentially corrupt in the transfer process. They aren't empty, and we can point this to a directory and have it process more than one file at once, so it can batch process and give us a log of any issues that helps whenever you have a large accession. We might, when we get the rail line network, that's a combined package of 2 shape files, but when you get something more complex or extensive, you might have hundreds or thousands of shape file clusters, and this would allow us to verify that they all are okay rather than manually going in and looking at every single cluster. So after the validation that we know that there are no viruses, that the data matches the schedule, and we have that base intellectual control of what is there, we move on to processing and verifying. And this prepares the records for preservation and access, and it allows us to get an idea of what these records are, which help our description. So we use a variety of NARA in-house tools and cost products to verify the content and structure, and we're always trying to optimize the types of tools we have to increase our capability for verification. These records are complicated, and the Esri shapefiles that we receive from the 1990s are much different than the shapefiles we might receive today. The shapefiles of today can be more complicated, so we need tools that are just as advanced. And originally, we used a USGS tool that has since become commercialized and is now the Global Mapper product to verify shapefiles, GML, KML, and various other vector and raster data. We can use Global Mapper. And we also verify the D-based tables in our current version of Microsoft Excel. But as Gregory mentioned, this will one day be an issue whenever our agency has Microsoft 2016, and we will no longer be able to open up these D-based tables. So here is a screenshot of Global Mapper tool. That's the verification tool currently used by DE to view every shapefiles and such. We're viewing the shapefile to confirm that the file is able to be opened and it hasn't been corrupted, that all the components are accurately relating to one another. Depending on the size of the accession, we might verify every cluster. If we have a very large accession, let's say we're ranging in the thousands or more, we aren't going to verify every single file. We'll take a random sample, which is another tool that was developed in-house that runs, it generates a list that is, for all intents and purposes, random to ensure that the majority of these records are okay, and we increase the sample if we find issues as appropriate. And we typically do this at the data file level whenever we're processing other types of records. But for geospatial records, it didn't seem as appropriate when individual files are sometimes not interpretable and you need that cluster to work in conjunction to depict the system. And as the record visualized in the screenshot is the railroad network system, so an accretion of that data. So we're opening up that single shapefile, which then serves as a verification of the index and the projection data and such. And as you can see, it might look odd that we don't have a base map here, that these points and lines are just on a blank canvas, but that's because when we're transferred records, we're only transferred the material from that system. We aren't given a base map that we would use. We can take and add a base layer to that to confirm that the points in California are indeed where California would be from that base map, but that isn't a required process. Going into further processing and verification, once we've verified that the shapefile opens, we drill into the feature information that's available in Global Mapper, and we're verifying that the file is legible and producing expected content. So we're verifying that the D-based table is coordinating with the shapefile, and then we also open up that table in Excel and verify that the same point has all expected attribute information. And it can also be used to verify the geographic coordinates, and we are making sure that the geographic area depicted matches what is described in the schedule, and it's described in the metadata. So we'll check that XML file, we might check any agency-developed documentation, and just make sure that all the areas that are mentioned are actually depicted. Moving on to processing and verifying of GeoTIFFs, JPEGs, PNGs. So these are examples of geospatial holdings at NARA. Those are products of the Federal Emergency Management Agency, or FEMA. These are flood insurance rate maps. And the map on the left is a GeoTIFF, and the map on the right is a PNG. Both products were transferred with companion world files, DW and TFW, that provide the raster geolocation. We can use Adobe viewers such as Acrobat Pro, Photoshop, Illustrator, even Windows Media Viewer to show that the file has content, is legible, does load, it's not corrupt, and then we would verify that the world file does show the area depicted. And this, again, we could go through a sample of these files. For the FEMA flood maps, we've received tens of thousands of these maps, and that's only a fraction of the data that we will receive. These records are currently available on FEMA's website, search and download and viewing on their site. So we're actively processing these records, but typically these wouldn't be candidates for the catalog because they're already being housed on the agency website. They're a lesser priority, but a priority nonetheless. And moving on to preservation, so once we've processed these records and we've verified either the sample or that the entirety are well formed, we would move on to ingest into our repository. And the process of ingesting, our current repository is called the Electronic Records Archive, or ERA, and this is where agencies create the transfer request, the legal instrument that would transfer the physical location and then the legal custody of those records from the agency to the National Archives. And this is also the application that the National Archives uses to ingest records and house records for preservation. So these geospatial records are packaged into zip file containers and then transferred via FTP to the server locations. And once the records are FTP'd, we verify that all the packages, there was a one-to-one transfer, that all the files and bytes match, that there was no loss. If there's ever any issues where a package might have been dropped, we'll troubleshoot that and re-transmit that data until we are ensured that every file and every byte is accounted for. And once the records are in the repository safely, we can start the description process. We create descriptions for every series of records that we have, and we can create file units for each accretion. Then we can drill all the way to item-level descriptions to describe individual maps or individual shapefile clusters and what that project is, how many files are in that cluster, and so forth. So all series and file unit descriptions are available on the National Archives catalog. You can see, even if the file itself hasn't been uploaded, you can see the description, and that helps our researchers determine if this is relevant for them to contact the records division and get that data. So the reference staff are often interpreting. They provide information about the records by interpreting the documentation and metadata. And unless the records are available for download and view online, researchers can only access electronic records currently by obtaining reproductions of them. So they'll order these reproductions, and the reference staff work with them to get them that data. from the National Archives catalog of a geospatial holding that is available for download. This is from the Bureau of Land Management, and it contains 3 every shape files and 19 shapefile component files. And I actually was the individual who helped coordinate with reference to determine how we would serve these records. And we had decided to zip the files. In that zip file, you have a container of a README file which describes the records, and it also explains how each component files are related. We were worried that if we allowed researchers to download each individual file, they might only click the shape file because they might not be familiar with how each of these components work together. We thought the zip file was maybe the most foolproof method. So currently at the National Archives, we've greatly expanded how the agency processes geospatial records, and much of the material that's been covered in this presentation has only come into practice in the last few years. So we are still actively developing our capabilities, and we understand that there is certainly room for improvement. And one of the areas that we could improve would be our verification capabilities. So Global Mapper has limited its verification capabilities. This software isn't able to confirm that all points and lines in a shapefile are connected, which would be a verification parameter that we would like to have as an agency or as an archive. And we don't currently have the capability to do LiDAR data at the moment, and we are in talks of transferring petabytes of LiDAR data. That's also a viewing capability that we would like to have in the near future. And Global Mapper has limited conversion capabilities. For example, the software doesn't support the conversion of Esri shapefiles into GML. We can view GML if we're transferred it, but we couldn't create a GML file from an Esri shapefile at the moment. And another challenge that we've had is preserving an immense volume of records. So many of these geospatial accessions are incredibly fast. The National Atlas had over 1 million files. The Disaster Planning Atlas from the National Geospatial Intelligence Agency contains about 550 files, but that's also 784 gigabytes. And these immense volumes currently, they're difficult to ingest into our repository. So our current repository, we're holding these immense records in internal storage until we can upload them into our new cloud-based repository, which should happen later this year in the summer. Because our cloud-based repository, E-ARK 2.0, which is supported by Amazon's Web Services, it does not have the same volume hang-ups that our current repository does. It can handle more file formats. It can handle the ingest of zip file containers, and it won't explode those zip files into their components. So in our efforts to overcome our challenges, in the past year, we've done an evaluation of FME desktop, and we've also evaluated server and research on FME cloud as a solution for National Archives. And we've seen that the FME desktop tool provides an automated workflow environment, and it can validate over 300 geospatial file formats to convert. The National Archives provides guidance that had mentioned yesterday of various file formats that are recommended for transfer. And often we might receive files that are out of guidance. And FME will provide an automated and repeatable process to convert those out of guidance files into in-guidance files. One example we have is a transfer of intergraph raster files. We had CIT and CRL files, and FME helped show us the process to create a workflow to convert those into geotips, which would be then viewable much more easily than the CIT and CRL files were. It would also provide those advanced verification capabilities that Global Mapper currently does not, and it creates a log for the verification and conversion process so we can see any changes that were made, any errors, and that could become part of the National Archives created documentation for those records. So our group that performed that evaluation, we've submitted our recommendation formally, and we are awaiting funding to procure this software and hope to have this software within the fiscal year. So moving on to E-ARK 2.0, which I had mentioned before, it would solve our challenge of accessioning immense volumes of records, and it should have increased capability. It would support cloud-to-cloud transfer, which is much more common now for agencies. Agencies are expecting that, and they don't want to work with physical media as much. Many agencies don't have the capability to take data from their system and write it to media. The permissions issues, so they'd see working with our IT department to coordinate these cloud-to-cloud type transfers. That would be definitely an advancement in our capabilities. So I turn it over if anyone has any questions, and thank you again for inviting me to this conference. And please feel free to email me or contact me if you have any other questions. And I apologize for
Can you hear us, Rebecca?
The issues. I couldn't have the YouTube live broadcast at the same time. We would have issues.
Computer only. Yeah. Oh, no, it's okay.
And see if we have any questions. Please feel free to follow
Going
up
to sleep?
via.
Try their Horwe. Try to ask her that.
Okay, hi, can you hear us? 1, 2.
Nope.
Rebecca, can you hear us?
I think Rebecca left.
And we had so many questions for her, right?
Just check on participants. See if she's still there.
I doubt
she's
No,
there.
I don't have any control over this.
Okay.
This is just a view screen.
Do I have it?
No, you don't have any.
Do you see the mouse there?
Yes, you do. Yes, I do.
Okay, but I don't see the screen where the mouse is.
Okay. So
Okay,
we see only this screen, not that screen.
Nearly. There it is. There you go. Yeah, she's there.
Okay. We're not off, right?
Okay, can you hear us, Rebecca?
Rebecca, can you hear us? I guess she can't.
Okay, wait a second. It's so awful to write that way. Where's the...
So there is nothing on that display over there.
No.
We need that screen, Yaka. This screen here.
It's testing.
Okay. But we can't see it to okay it.
Yeah, we...
Okay, now we have both screens. Thank you.
Okay, great.
But
So
it's-
just do okay. Okay, right. Yeah. Can you hear us, Rebecca? Can you hear us? Oh, she's
now
saying
we can't
something.
hear her.
We can hear her now.
No, we can't hear her. She's not muted. She's not muted. She's not muted.
Are we muted?
No, we're not muted.
Okay.
No, we're
Can
just.
you hear us?
Yes,
Can you hear us, guys?
yes.
Yes.
Can you hear you?
Yes.
You can hear you. We can hear you.
Right.
Can
Do
you
we
hear?
have any questions?
Fast. Jenna, calm down.
Okay. Yeah. No, I'm calm. I'm calm. No, I don't think we've got any questions.
Do
So-
we have any questions?
Yes.
Yes,
Gregor's
we have.
got a question. One question. Right. This is.
You should come here to the microphone, I guess. Yeah, go there, please.
So hi, this is Gregor, and I have a question that I had in the DC, and maybe it would elaborate to the people here. Why don't you use open source tools?
So that is a decision that is well above my pay grade and division. I have recommended, in my first weeks of being here, I recommended that our division use it because in my own work as an archivist, I've used it, I've georeferenced with it, it's usable, and I feel like there's a great community supporting the tool, but unfortunately, it could not get past our general counsel. So every tool, in order for the National Archives to use it, we have an IT governance board, and that board has to review the software, and they need to review the licensing agreements or any type of user agreement. And if that doesn't pass what the lawyers are willing to work with, whatever risks they might be willing to take, then we are limited to tools that pass that test. We also have, there's a lot of issue trying to work with international tools. So tools need to be FedRAMP certified, they need to be on a GSA schedule, and that's how we were able to look at FME as a solution because it is on the GSA schedule. So we definitely have these boundaries that we need to operate in, which I do think constrain our capabilities.
The GSA is the General Services Administration. This is Brett. And so they are the procurement police, for lack of a better term. And so that's what Rebecca's talking about is approval. Companies have to go through an approval process. They get accepted onto the list, and then they can become considered as providers for every federal agency. So that's how it actually works. But one thing that you guys, many of you are archives, and you all are aware that we're built either by media silos or other types of internal divisions and structures. And so the E-ARK tool that we were talking about, the web Amazon site, every department that deals with digitized records needs their tools to be incorporated into this E-ARK platform. And so because we're talking about presidential libraries, we're talking about the Congressional Holdings Division, we're talking about the still photographs, motion picture photographs, cartographic eventually, and also the Electronic Records Division. We all have to play nice together and submit a request for the kind of tools that we would like to be incorporated into E-ARK. And then, as Rebecca says, it goes through this architectural review board, and they are slow to accept any tool. And so we are now in a queue waiting for approval on email tools, which everybody agreed we all are dealing with emails, and they're very high profile. So therefore, we want the email tools to be included. And that may take 3 to 4 months to just get on the table of consideration. So we don't know where and when the geospatial tools will be made available through the ERA method. So
I think that's one reason why we looked at FME, because it also can support XML, structured data, HTML, it has PDF wondering if we ask for one tool that can do many things, that request may be accepted much more easily than asking for a suite of tools that might use certain applications. But our agency has relied on in-house development for a lot of small, simple tools. So we're getting a little bit of pushback about asking for such a dynamic, robust tool rather than small tools that could be created in-house.
Okay, thank you very much. So I thank you for your contribution to this conference. It was very informative. Yeah?
Gregor, can I ask some questions of the other archives? The people that are representing you guys and some other archives?
Yes.
I'm curious to know how much digital data that is geographic are you guys actually dealing with? Not the stuff that's created from maps, but the actual born digital stuff.
I think that the best archive to answer this question is the Danish National Archive, because I think they have the most experience and the largest volume of geodata that is digital born. So maybe a question to Jacob.
But you'll have to come
Yeah.
here, please.
Okay, Jacob's coming now. So.
Good, thanks. Maybe we can see it.
Hello?
Okay.
Am I?
Hi.
Yeah. That's a tough question, actually. We've had.
Could you just introduce yourself?
Yeah, I'm Jacob from the Danish National Archives, and we have some, as Gregor mentioned, some experience archiving geodata. Let's see. I would think it's in the terabytes we're dealing with, but we're still quite inexperienced in some raster formats. So it's primarily at this point vector geodata. But the entire public administration of Denmark produces a vast amount of geodata several times yearly. So, for example, orthophoto aerial imagery of Denmark is made on a national coverage 3 times a year, and they have 3D, not 3D, aerial photos from the side, like Google does. That's also produced once per year.
So what format are you saving those records in?
Well, at the moment we don't actually have because we are very focused on automated tests, and so we have an overarching legislation, and then we have a detailed instruction for vector geodata, and are working on having a detailed instruction on raster geodata. But at the moment we're considering either GeoTIFF or JPEG 2000 combined with some projection.
The vector data that you guys are bringing in, are you bringing in shapefiles? Are you bringing in GML?
We're bringing that in GML 3.1.1 and are probably gonna be inspired by the E-ARK for all e-archiving building block under the European Commission. So GML 3.2. Yeah.
Okay. So one more question. When you saw the presentation and the amount of work for validation and verification that we do on our geospatial stuff, did you have any impression? Did you think it was excessive? Did you think it's necessary detail? I'm kind of curious to see what the overall impression of our efforts are. And please be honest.
Well, to me, in a Danish context, because we have the necessary legislation to ask a lot of the agencies, it seems like you pretty much accept whichever geodata format you are given, whereas we can make the agencies comply to a very strict legislation So the GML is very well documented in the end, also to a degree, a further degree than it's perhaps documented in production, I'd say.
Wow. So then, if you get a GML shipment, you basically, you do a quick review of it and then accept those records, as opposed to what we were doing?
Well, we at first we specify in very great detail how the submission information package is supposed to look like according to the legislation, and then we perform automated and visual tests on the actual vector geodata and the local application schemas for each geodata set. Split up into different geometry types, so point, line, string, and polygon, so on.
And this is what Gregor developed with the crew that Gregor developed that was built into the E-ARK project? Is that the SIP evaluator? Is that what we're talking about?
For the testing.
I'm sorry.
For the
Yeah.
Oh yeah, the CIAT, yeah. The Danish National Archives have a sub format of the CIAT, which we call CIAT DK, but we have been working with E-ARK on both the E-ARK project, CIAT 1 and 2, and the E-ARK for all with the new e-archiving building block. But we have a national specification format which differs a little bit from the current CIAT 2, for example.
Right, but with the geospatial, wasn't the E-ARK project, wasn't part of what was built into the E-ARK was an evaluator of geospatial records when a SIP, to evaluate a SIP file through the E-ARK tool? I thought that was something that was done in 2017 as part of the project. Am I wrong, Gregor?
Yeah, Janet is sitting here telling me yes.
Yeah, Anders Boe and Philip are working on that. They're not with us today, but yes, yes, Brett, they're working on the validators.
So the validator,
Specification
then,
validator.
This is what you're talking about, that you have an in-house tool in Denmark that evaluates a ship from an agency that say that all the elements are
Yes.
there, and that's what you use.
That's what's under development in E-ARK for all, which finishes on the 31st of May. So that's being developed now with Philip, Anders Boe, and the OPF. So Carl Wilson from the OPF, and Karin, and everybody. Yeah.
Wow. Okay. Well, thank you so much for listening to my questions. I think what we do is an excessive amount of stuff, and I just wondered if it appeared that way to you guys since you're seeing it. Yeah, so just curious.
Okay, we thank you for your contribution now.